Virtual memories. Now, the main objective of memories are by keeping the cost constant and how can we increase the size and speed of the memory. Now, by introducing the cache memories, the gap between the processor is a high-speed device and main memory is a low-speed device. By introducing the cache, the gap between the processor and memory is reduced. Now, by using the virtual memory concept mechanism, now try to reduce the gap between the main memory and the secondary storage device. Now, it is a large memory capacity and main memory is having the less storage. So how can we reduce the gap and speed between these two that we will discuss in the virtual memory concepts. Now addressable memory space depends on the number of address bits in the computer. If the k number of address bits are there, then the address space or memory size is equal to 2 to the power of k. Now, for example, if the computer issues 32-bit address, then the total addressable memory is 2 to the power of 32 is equal to 4 gigabytes. But physical memory in a computer is generally not as large as the entire possible address space. Now here the physical address is how much? Only maximum up to 1 GB. But how many addresses address bit it is generating? 32. For this maximum 1 GB means how many addresses? Only 30. But computer is generating the 32 means what? It is showing that address space is 4G. Now here the main memory is having 1 GB. Main memory is having 1 GB and the secondary storage device is in the order of tera. But here in between the address space or virtual address, we can call it as a virtual address, is what? 4 GB. Means what? How the main memory can look like a 4 GB means, so part of the secondary storage device is taking and it is, now this is the main memory size, 1 GB is the main memory size, and part of the main memory is considered it as a main memory, secondary memory is considered a main memory, and it is considering it as a total virtual memory. Now we can execute the program which is larger than the 1 GB. 1 GB is a physical address, physical memory address. So we can execute the program which is having the large capacity which is greater than 1 GB. So how can that possible means what? That program, complete program where we store in the secondary storage devices like magnetic disk. So program is stored in the secondary storage device. That program is divided into parts. That part is called as a page, and page again it is a group of words. Now which page is going to be executed? Now if the program is 2 GB, then completed 2 GB is supposed to be bring into the main memory to execute. But at a time we can't transfer into the main memory because the main memory size is only the maximum is 1 GB. So how can we execute this 2 GB program? Means part of the program is brought into the main memory and that will be executed by the computer, and after that again this part will be again moved into the secondary storage device, and the second part or new part will be moved into the main memory. Like that, the automatically swapping the part of the main memory, automatically moving program and data blocks into the physical main memory when they are required or execute when for the execution are called virtual memory technique. Now swapping the blocks or pages from the secondary device to the main memory and is called the virtual memory technique. So because of that, the main memory uh, physically main memory size is only 1 GB, but it gives the illusion to the user that the main memory size is larger than the existing. So this is nothing but a virtual memory concept. Now if we see the diagram, this is virtual memory organization. Here the processor is there, and nearer to the processor cache memory is there, main memory, and after that disk secondary storage device is there. Now processor will generate the virtual address. So here in the last example, 32 bits it generated. And MMU is one block, which is nothing but a hardware circuit, which will convert the virtual address into the physical address. Physical address is nothing but the address indicated for the main memory. physical address is what? 1 GB. The maximum size is only 1 GB, right? So for that, how many number of bits are there? Only 30 bits. So these 32 bits should be converted into 30 bits. Then which device is converting? MMU. MMU is nothing but what? Memory Management Unit, which will translate virtual address into the physical address. Now, after translating, it will check whether the address is available in the cache. If it is available, and data will be accessed by the processor. If it is not available, then it will go to the main memory and it will check in the main memory. If that is available, then processor will access that data. If that is not available, if the physical address is not available in this main memory, then that is called as a page fault. Page fault. And when the page fault occurs, then MMU will activate the OS. MMU will activate the OS, operating system, to transfer the page from the secondary device, hard disk, to the main memory by using the DMA transfer. Now, how this is happening, we will try to analyze in detail in the address translation. Now, address translation means what? That virtual address, how it is converted into physical address, that we are going to discuss here. Now, uh, for which now the complete program is stored in the secondary device, and the complete program is divided into pages, and each page is a group of words, and this is the main memory. Main memory is divided into blocks, and this block is nothing but what? Group of words. Now here the page size and here the block size both are same. Okay, now in the case of secondary device, we are calling it as a page, and in the case of main memory, we are calling it as a block, and in the case of cache, we can also call it as a cache block or cache line. Cache line. And here the block size and here the block size is same, and here the page size and here the block size is same. So here, if you see, the virtual address is divided into two fields. One is a virtual page number and offset. Offset is nothing but what? Each page is consisting of group of words. To indicate that words, here few bits are required. That is nothing but what? Offset address. Now, similarly, physical address, this block is also group of words. To indicate these words, we need few bits. Those bits are nothing but what? Here to indicate a word. So we need offset. Here both the sizes are same. That's why here the offset and here the offset, as it is taken. And the remaining what? How many number of the complete program is divided into the pages? How many number of pages are there? Depending upon that, these number of bits are there. These page numbers should be converted into the physical address is divided into page frame and offset. Here offset is both are same. And this virtual page number should be converted into page frame. How can this converted means? So if you see the page table is holding the page frame. So with that what? Now the page is, whenever the program is going to be executed, that page is moved into the main memory. So where it is moved, so that information is consisting by this page table. Now this page table gives the information about the page where it is moved into the main memory. And this page frame can be calculated. Now this page table is having one register, that is nothing but a page table base register, and page table base register is holding the page table starting address, and this starting address is page table address is added with the virtual page number. Then it will give one new page entry, that is called as a page frame. And also this page table consisting of few control bits. These control bits gives the valid. Now whether the page is loaded into the main memory, whether the page is existing in the main memory or not, that information will be given by the one of the control bit. If any new page is replaced by the old page, then that information will be given by the valid bit. Now valid bit is one of the control bit, and one more control bit gives the information about if any updations are taken place in the main memory. If the processor, after execution, if the processor is writing the content into the main memory, that updation information will be held by one of the control bit. If this page is replaced by the new page, that page must be updated in the secondary storage device. So that information will be held by one more control bit. And one more control bit gives the information about the program. The program may give the full read write control or only read access control, that is given by one more control bit. So these are the few control bits which will give the information about the pages. Now, how the virtual page is converted into the physical address, virtual address is converted into the physical address, we have discussed. Now this conversion is done by the MMU. MMU is nothing but what? Memory Management Unit. Now this memory management unit circuit is resided on the processor chip. It is mounted on the processor chip. And whenever the physical address, virtual address is generated, that will be converted into physical address, and MMU will check whether that page is available in the main memory or not. So for that, what this complete page table should MMU should have the page table information, but page table is having the huge information that can't be stored onto the processor. That is impossible. That's why this page table will be stored into the main memory. So part of the main memory is used to store the page table. So now every time, so MMU can't come and check the main memory. That's why what part of the page table information, nothing but what recently used page table information, recently used pages information is held by the TLB. TLB is nothing but what? Translation look aside buffer, which is a small cache which is incorporated on the MMU. Now, if you see, this is the TLB information, so which is having the for which page number, what is the page frame, it consisting of that, and also control bits. If any page is replaced by the new page, and that valid bit should be information is given by the control bits. Or if any new page is loaded, that page information also should be updated in the TLB. So recently accessed pages information will be held by the TLB. So if the page is available in the TLB, then that is called the hit. If the page is not available, then that is called the miss. Then thereby MMU will check the page information in the page table. If the page table information, if the page is available, then that is called the hit. If not, then the page fault. Thereby what? OS will load the new page into the memory. New page into the memory. If complete memory is occupied full, if the processor is searching for the new page, if the page is not available in the main memory, then the new page should be copied from the secondary storage device to the main memory by using the OS. Now, whenever the computer is needed any new information, if that information is not available in the main memory, that is called the interruption. So OS now immediately OS will be activated by the MMU, and the current executing program will be interrupted, and it will now the data transfer takes place from the secondary device to the main memory. If the main memory is completely occupied, then the least, by using the replacement algorithm, LRU, least recently used page will be replaced by the new page. Now this is the complete information about the virtual memory concept. Now by introducing this virtual memory concept, the gap between the main memory and the secondary memory gap of what speed and storage gaps between main memory and physical memory are reduced.